Okay, so our last review video, hallelujah. So we're still talking about equilibrium, and you should be able to write out equilibrium expressions. You should be able to explain that an equilibrium system is a dynamic process. You should be able to use particulate view models, draw particles, shade them so that you can indicate what those atoms are. Le Chatelier's principle tells us that when a system is at equilibrium and then an external stress or an external change is made to that system, that the system will respond to remove that stress. So you can either stress it by changing the pressure if it's gases, you can increase a reactant or a product, and you can decrease a reactant or a product. And you should be able to predict what will happen to all species in order for that stress to be relieved. So you should also be able to calculate Q and compare it to K so that you can determine which way the reaction will shift. This will also tell you, if you compare Q and K without doing an actual calculation, whether you're going to subtract X from the reactants or the products. Solubility product is a special case of equilibrium. You have a solid that is dissolving, and solids never appear in any of our equilibrium expressions, so you just have the concentration of the products raised to the power of their coefficients. And you should then be able to calculate the concentrations of the products, and that is called molar solubility. And when you multiply them together, it's called the solubility product, hence the name. Common ion effect, I am doubting you'll see this, but it is possible. All that means is when you have an ice table, you will start with your initials, but you will have maybe one reactant and one product, and not the other product. And so then you still do your ice table the way you would do it. You would subtract X from the reactant, add it to both products, but now you have to be concerned whether or not you can ignore X when you do the products for the one that was already there. pH and solubility, this is again just a special case of the previous slide. If you are doing a common ion, one of the common ones that they do is either hydrogen or hydroxide. And so you would have a certain amount of it already, and then you would want to see how soluble, let's say, acetic acid would be in a 0.02 molar HCl solution. If that were your problem, then you would take as your acetic acid concentration would be whatever given in the problem. The acetate ion concentration would be 0 initially, and then the concentration of hydrogen ions would be that 0.02 molar HCl would be all hydrogen ions because it is a strong acid. So, and then you just go through the ice table and continue on. Free energy of dissolution. This one is a hot topic right now with the AP groups, whether or not this will be included. It is certainly possible. I would not at this point spend a lot of time trying to master this if it was something that's difficult for you. If you feel the need, feel free. I'm not going to stress it. That is the end of our presentation. Thank you for listening.